Hi, everybody. Hi. Great. Okay. Last time, let's just quickly review what we've been talking about, and we'll get into some new stuff. Last time, we talked about algorithms. What is an algorithm? Nobody knows after all these times. What is an algorithm? Yes. Thank you. All right. If that is an algorithm, what is a program? Yes?
It's an algorithm written in a language that the computer can understand, or the computer can execute.
Excellent. So, it's a program expressed in a form that a computer can execute and humans can understand. Right? Okay, so this is the algorithm we were going through last time, and we did it in kind of the form of an outline rather than a flowchart. And we were stepping through this, and this is an algorithm that will essentially tell us if a number is even or odd, right? So here's what we did. We did some input to tell us a number, and this was essentially start, right? Pound include IOStream using namespace standard, int main was the equivalent of start in our flowchart. This should just be a review so we can get back to where we left off. We also talked about stop, which in this case is return 0. That's how you stop this program. And then we started talking about input. And one of the inputs we wanted was to tell us a number. But before we got there, the program had this other stuff. Do you all remember what this other stuff was? Yes, sir. And why do we need variable declarations? We have to remember the computer is stupid, but it's stupid very, very fast. And what it can do is it can get something from memory and do stuff with it and put it back. That's about it. It does a little more than that we'll talk about, but that's about it. So before we use these memory slots, we have to tell the compiler what we're using them for. And we also give them a name. Does the computer care about the name? How many of y'all think it does? How many of y'all think it doesn't? How many have no opinion on the subject? How many of you think we should attack Syria? Okay, well, I'm doing a poll. Okay, so the computer doesn't care about the name. It cares zero about the name. But the name is convenient for us. And the name is convenient for us because then we know what that slot is. If we give it a name that we know, then we can tell what that slot is being used for. So we have to tell the computer how we're using the memory. Hence, before we got to the input part, we declared the variables we're going to be using. And we'll talk in more detail about this. Okay, the next part was input. Tell us a number. And we're going to use, in this class, cin and some other things, but right now for cin, to read something into input. And what is input? It's this variable we declared right up there, right? So it says, read something from the keyboard, and whatever value you get, stick it in that variable input. Sir?
Because int is integer, right? What if you don't put it in an integer?
So the question is, int is an integer. What happens if, the user makes a mistake? I know it's strange for us to talk about humans making mistakes, right? How many of y'all ever made a mistake? One or two of you. What happens when people make a mistake and they put in something that's not an integer? The answer is bad things. And we will talk about that in detail later. But for right now, let's just pretend that we're not going to make mistakes. So we read something in, we put it into input, it gets stored in that variable. That is how we do input for right now. And if we want to match it to the flowchart, it's a flowchart for input. Okay, the next step is to do calculations and divide the number by 2. This is actually pretty straightforward. We're going to say the remainder is equal to the input, and this percent sign we'll talk about more in detail, but it's called mod, and it does integer division, and rather than telling you how many times it goes in, it tells you the remainder. Okay? So this says input mod 2, and it says input. The computer goes, oh, I remember something called input. It's a box over there in memory. I will go and get whatever value's in there and bring it back. And when I get that back, I'm going to say, okay, now mod 2, which means divided by 2 and figure out the remainder. So it does this operation, gets things gets the variable called input, divides it by 2 and figures out the remainder, and then this equal sign says take that thing that we just computed and stick it in this other box called remainder. So when this is all done, the remainder, which is going to be 1 or 0, will be stored in that box named remainder. Okay, everybody with me? Who's against me? Okay. Now, our next step after doing the calculation, and this is just a general calculate box, and we'll talk in great length about the different calculations we can use in C++. But if you want to match it to the flowchart, that's what it looks like. Then we do a decide. Is the remainder 0? Right? Do I still have this backwards? Yes, I do. Man, it's like the error that would not die. That's what I get for cutting and pasting and putting things everywhere. Okay. So now we divide. Now we look at we have to make a decision. And we have to decide whether the remainder is 1 or 0. If it's 1, the number's odd. If it's even, 0. The way we do this in C++, one of the ways, and we'll learn another over the next couple of days, is called the if statement. The if statement is one of the ways that we make a decision. Now the if statement always has parentheses and something inside those parentheses. The thing that's inside those parentheses must always be something that's either true or false. And I'll talk a little bit later about what actually constitutes something being true and false, but I'll tell you right now the secret to it. If whatever is in there is 0, it's false. If whatever is in here is not 0, it's true. Okay? And we'll talk more about that later. But essentially, we have this here. This is a boolean expression, and it's either 0 or it's not 0. Now you're looking at this, and you're saying remainder equal sign 0. Does this seem a little bit weird to you? How many of y'all think that seems a little bit weird? So this equal sign up here, as we'll see, is called the assignment equal sign. It says, take whatever's on the right-hand side of that, whatever value, and take it over and stick it in the box in memory that's on the left-hand side. The single equal sign is called assignment. Now because of that, we can't use single equal sign to tell if two values are equal. Instead, we use this double equal sign. Equals equals is a comparison operator rather than an assignment operator. And I'm just giving you the quick overview, and we're going to go into this much more deeply. So this says if remainder is equal to 0. Oh man, I messed up the program too. Gosh, now everything's out of whack. I don't know if I can change this one really fast. Sorry about that, I'm screwing up everybody's notes. Okay, so if the, except the code is backwards here. See, now I've made a mistake today too. Okay, so if the remainder is 0, then it's going to output even. Otherwise, it's going to output odd. So here's how the if statement works. We have some Boolean statement, and then we have what happens if the statement is true. Else, down here, we have what happens if the statement is false. Now remember, on the decision, we could branch and go 2 different ways. This is how we split up to go 2 different ways. If we go this way, it's true, and if you have the else, it's false. Okay. Now I'm just going to tell you the else statement is optional. Sometimes you don't want to do things if it's false, so you can just have if without the else. We'll talk about that in more detail. And then finally, return 0. What was return 0? Oops, except I'm skipping stuff. So this was, remember, if remainder is equal to 0 was our example of a decision. Here's how we do output. And I went over this quickly at the end of last class so that you would have part of what you needed to do the assignment that's due on Thursday. And we do output. Output is C out. C out is how we do output. And we have these double angle operators that tell it what to output. And we'll talk about that in detail. Question?
Well, just earlier you said about the if statement.
Uh-huh.
If it was 0, it was false.
Yeah, my slides are all inconsistent and screwed up. So,
Just about this program in particular, not.
yes. Yes. If you divide something by 2 and the remainder is 0, then it's an even number. If you divide it by 2 and the remainder is 1, it's an odd number. Okay. Now that I've completely mixed up everything, because I think my slides are all backwards. Yeah, see, I have odd and even reversed here on my algorithm from how I did it in code. So sorry about that. Bad professor. No candy for me. All right. But is everybody kind of on board with this, even though I've done my best to confuse you all? Question? These curly brackets, also called braces? It's a style thing, and we'll talk about style. Okay? The answer is no. In fact, in C++, the entire program could be on one continuous line 14 miles long if you wanted. Whoever had to read your code would hate you, and they would find you and call you bad names and kick your dog or something like that, okay? But we'll talk about programming style as we go along. I'm trying to just give you, here's what I'm trying to do pedagogically. I'm trying to like give you an overview, and then we'll go back and we'll like do it again, except we'll go in deeper. Does that make sense? I don't know if it's working or not. You'll tell me. So, another question.
CN only requires one
We'll talk about that later, okay? Just trust me right now. We can input a lot of things, we can output a lot of things. In this example, CN only had one variable to input, so there's only one thing there. There can be more. I swear to God, I will get there, okay? All right, so output. Cout, inside the double quotes is whatever words you want it to output. So if you have a message you're trying to print out, you put it inside double quotes. And this ENDL, as we'll see later, anybody ever heard of a thing called a typewriter? They were obsolete long before any of you were probably around typewriters. Anyone? Anybody ever use a typewriter? You were trapped in some third world country. Okay, so you type in a typewriter, and when it reaches the end of the line, it doesn't automatically wrap around. What do you have to do? Yeah, you either push the return button, or if you have a typewriter, you can push, right? So what the end of line does is it says, okay, I've printed this word. Now anything else I want to print, I want it to start on the next line instead of all being jammed together. And you'll see that as we go along. Yes?
Do you have to put quotes around any output or just if it's a word?
Just if it's a message that you're trying to print out. And we'll see later how to print out variables. When we print out a variable, we will not use the quotes.
So if you want to just put out like number 1.
I will answer all your questions someday. I promise. I just can't teach you everything at once. And so we're going to go, like I said, we're going to go in more deeply. Okay? So trust me on this. Right? I know you want to learn everything. I will teach you everything. But I can't do it like in parallel. Okay? All right, so here's how we do output. If we're just going to print a simple message, use cout, and then return 0, as we talked about before, was stop. Okay. So here's what we've started to do. We've started to look at taking an algorithm and turning it from like an algorithm we think about into C++ code that actually does something. Okay? Except I did all that for you. Right? Now what we're going to do is we're going to do this all again. Okay? We're going to develop an algorithm here in the classroom, and as we go along, as we touch each piece of the algorithm, I will talk to you a bit about the piece and how it's working, and we'll go into more detail. Okay? Everybody happy with that? All right, do you want to stand up and take a stretch just for 1 second? No? All right, 1 minute break. Yes?
The NDL is just to tell it to go to the next line.
Yeah.
It's not to tell it to print any lines. It's syntax different.
It just tells it when it prints out to like go on to the next line. So
I wanted to print a blank line that we could that's a different thing.
I will answer all your questions about printing. I promise. Just. All right. So that was about a minute. Welcome back. How y'all feeling? So, do you remember this picture? We saw it earlier. This is a flow chart that tells us how to do what? Write a program. and get a program complete for this class. So what is the first step? How many of y'all have already started on the assignment that's due Thursday? Awesome. How many of y'all have finished? Fantastic. That's great. Okay, so the first thing we do is start early. The next thing we do is read problem. But I'm just going to tell you what the problem is right now that we're trying to do, okay? We want to divide two numbers. Does that sound hard? Should be pretty easy. But we want to give the user the choice of whether we're going to use decimal division that gives a floating point or integer division that gives the number and the remainder, okay? Because when we do division, we can do it either way. So this is our algorithm is going to be, the problem we're trying to solve is we want to divide two numbers, but we want to give the user the option of doing it as a decimal number or as an integer, okay? Everybody, does that make sense? And we'll see this as we go along, because sometimes you might want to divide 7 by 2 and get 3.5, and sometimes you might want to get 3 with a remainder of 1. Okay. So that's our problem. So let's start designing the algorithm. How do you all like designing algorithms? Well, you don't have any experience yet, do you? So how about I start designing the algorithm for us? And here's what we're going to do, if we can get back to where we're going. Okay, here's how I normally design algorithms. This is my editor window. I use a program called Emacs instead of the program Nano that you're using. Emacs is much more full-featured than Nano. However, it has a very steep learning curve. In using Nano, you're essentially using kind of the equivalent of those scissors they give like kindergartners that are not blunt on the tip, so you can't really hurt yourself. Emacs is the equivalent of a chainsaw powered by a snowmobile engine, okay? It's very powerful. However, it takes a while to learn how to use it, okay? I've been doing this for a while, so I'm just going to use Emacs. You're welcome to switch editors as you go along during the semester. I just, tried to give you an easy one up front to keep the amount you have to learn ahead of time down, okay? So I'm using what's called Emacs. And throughout the semester, what we're going to be doing is I'm going to be doing a lot of coding up here in this. And then when it comes to compile, I will switch down to the other window, and I will do all my compilation in the other window. How many of y'all watched the screencast about the assignment? Were they helpful? Good. I'm glad. Okay. So here's how I normally do an algorithm. When I sit down to design an algorithm, I do it in the editor window. But what I do is I use what are called comments. Now, in C++, you can put notes to other programmers that the computer ignores, okay? And they are called comments. Remember, a program is an expression of an algorithm that a computer can execute and that people can understand. You can help the other people understand your program by leaving notes for them in the code. And this is called a comment. So this, what I'm showing right here, is what is called a comment, right? And you notice it's a slash with a star, followed by a number of stars and a star slash. This is one way of doing a comment. And in fact, what this is what's called a C-style comment. Now, the reason it's called a C-style comment is because C++ is a computer language that has evolved from an earlier language named C. So C was the original language, and C++ evolved from that. You can think of C as the Latin to the French of C++, or the Spanish of Java, or the Italian of something else similar. Okay. So C is kind of this language that was around. It was one of the original ones, and then a lot of other stuff got developed off of that, C++ being one of them. So C++ still accepts these things called C-style comments that have the stars. The other way that we can do comments is with a double line. And if you put a double slash at the front of any line, that is a comment. Now, as we'll see later, you can also put comments at the end of lines. You can put like a double slash after a line of code if you want to put a comment about a particular line of code. But in general, we do this. As time goes on in the semester, what I'm going to show you about comments is that comments can be really helpful. And what we're going to do is we're going to show you something called JavaDoc comments. And what JavaDoc is it's a program that reads your program and it pulls out all the comments and it makes them into a nice web page. So people who want to read your code and understand it can run JavaDoc on your code, and this web page pops up that shows all the pieces of your code and what they do. It's awesome. Okay. So, all right, but for now we need to know that there are these things called comments. If we were to compile these, when the compiler runs to turn this into a program, it just throws them all away, because these are only for other people reading your program. So here's how I actually like to develop my algorithms. Whoops. And this is how I develop algorithms when I'm developing things for the class. I actually sit down and I write an outline of my algorithm in the comments, right? So you know that kind of outline form I gave you? I just write that on comments. So here's our problem. Okay, so we're going to divide two numbers, and we allow the user to choose between integer and floating point division. Does that make sense? So if we think about that, if we're going to divide two numbers, where do we get the numbers from? Pardon? So the fact that we have two numbers implies that we're going to input something, right? The user has to input the two numbers they want. We're going to allow them to choose between integer and floating point division. What does that imply? Yeah? Both of you. Yeah, it just involves a decision, and what are we going to decide based on? Okay, what are we going to decide based on? User input, right? The user has to tell us whether they want integer or floating point. So we know right now we're going to have to input numbers to be divided, and we're going to have to get some sort of choice from the user about what they're doing. Okay, does that make sense to everybody? Yes, sir. So we'll talk. We could write this all on one line. We could put it on multiple lines. For comments, as long as at the first part of the line is either a double slash or one of those stars after a star slash, it's a comment and it's ignored by the compiler. Okay? So all that I'm typing here is just for us to read. The compiler will ignore it. Okay, so we're going to divide two numbers. So what we're going to have to do is we're going to have to input numbers to divide. We're going to have to input a choice for int or floating division. Okay. Does that make sense? Yes, question? Great. Why not? So the question is, wouldn't you want to choose between int and floating point first? Absolutely. In fact, I would probably do it that way. So let's rearrange this algorithm. An algorithm is an ordered step by step. So let's put that before the other things. So I will get rid of this line and move it up here. So first we're going to input a choice, and then we're going to input the numbers to divide. Absolutely. Sure. It's your choice. But in my mind, I would do this first. This is going to be a pretty simple program. We're going to be dividing, and I actually should say, we're going to divide two numbers, but when I say numbers up there, I actually mean two integers. Okay. Okay, so here's how we develop algorithms. Well, this is what we're trying to do, and here's how we break it down into smaller pieces. Obviously, we're going to have to make a choice, what we're going to do, and we're going to have to input some numbers to divide. Okay. Now, here we are, we've inputted the choice, we know what it is, we inputted the numbers to divide. What do we have to do next? Do we do the division right away? Do we do the output right away of what the result is? How can we do the output if we haven't computed the result yet, right? So we have to take into account like how the computer does these things and make our algorithm work that way. So the first thing we have to do, probably, is decide whether we're going to do integer or floating point. integer. And what do we do if we're going to do integer division? The answer is you don't know yet because we haven't really told you how to do division, but we'll get there. If so, what we're going to do the first thing we're going to do is we're going to do the division as integers. We'll do integer division. That will tell us how many times again. And then separately, we also have to figure out what the remainder is. Okay? Because we don't have a single operation that gives us the division and remainder results in one step. And then once we've done that, we can output the integer results. Because now we've computed them. Okay? We were able to choose whether we're doing inner floating point, input the numbers, we divide the two numbers, and we can output the results. And the results are actually going to be what we call the division results and the remainder, the mod results. Similarly, what do we do if we did not do integer division? Yep. Mm-hmm. And do we have to calculate the remainder? Why not? There's no remainder. The remainder gets pushed into the floating point, and then we just output okay. Then what do we do? Yes. Stop. Absolutely. It's an important, a very important part of the program, is knowing when to stop. All right. So, right now, we have just outlined our whole algorithm. Okay. Everybody with me? Does it make sense? Yes?
So why do we not need any sort of, do we not need a variable declaration for this?
Okay. So for the algorithm, for the outline portion, we don't need to worry about how we're going to declare variables yet. Okay? That, when we get into C++, we're going to have to do that because this is an expression for us, for humans, right? The humans don't actually keep track of all the variables, so we don't have to worry about that right now. But when we actually do it in C++, we are absolutely going to have to do this. And I'm just going to tell you, we're going to post the first programming project this afternoon, probably. It'll be due like 2 weeks from Thursday. And there are a lot of variables to declare for this project. And so I don't want you to put it all in your algorithm because it would be like 50% of your outline would be variable declarations. Okay. All right. Everybody with me so far? Does this seem pretty easy? How many not sure it seems easy? On a scale of 1 to 10, where 1 is we're back in kindergarten again and we're trying not to cut our fingers with the easy scissors while we paste things. 10 being this is differential equations of organic chemistry. 573. How many of you are like a 5 or less for this? Okay. 8 or less. Okay. All right, good. I just get worried when I don't get feedback. Okay, so we've outlined our algorithm, and now, since we have all the comments here and they're already in the same place we're going to write code, we can actually work from this and start putting code in underneath each of the comments. Does that make sense? So, one thing that we forgot up here was start. What does start look like in C++? Yep. Pound include IOStream using namespace standard int main That's how we start. And you know what? I just like to go ahead and put stop in there too when we're nearly done. So right now we have a C++. This is a valid C++ program that does nothing, but we have great plans and aspirations for it, right? Okay. Let's just talk 1 second about this stuff. We have pound include IOStream using namespace standard and int main. What are pound include IOStream and using namespace standard? Magic. But I'm going to break down the magic for you a little bit. Pound include IOStream. Do you remember at the beginning of the semester I told you that programmers are lazy, but they're lazy in a good way and they like to reuse other people's code? Pound include IOStream means that we are including something called IOStream, which is a library. And it is a library that gives us access to functions that other programmers have already written for us, so that we don't have to rewrite it every single time. And IOStream stands for input-output stream, and it gives us the ability to do input and output using cin and cout, and some other stuff we'll talk about. Question? It is hidden away on the hard disk. It's there. If you want to go on your computer and search for IOStream, you will eventually find, it's probably not named IO, it depends on the computer, but it's in there and the compiler knows where it is. Okay. Later, if you want to use other libraries that aren't part of the thing, it gets a little more complicated because you do have to tell the compiler where to find them. But I don't want to scare you away by doing that yet. Okay. Once you understand what's going on, it's actually not that hard, but it's conceptually kind of complex. Okay, so pound include IOStream is a library, in this case, that lets us do I/O. And what's going to happen over the course of the semester is we're going to see other libraries that we need to use that give us additional functionality so we do not have to write it ourselves. Okay. How many are happy that we get stuff we don't have to write ourselves? That should be all of you. If only there was like pound include COSC-051 and you could just, pull library functions out, the class would be a lot easier. All right, so that's what this pound include is. Almost every program is going to have pound include. I mean, every program we write in this class is going to, and every program you ever see is probably going to as well, because programmers are lazy and nobody wants to ever rewrite all this stuff. Okay. Using namespace standard is still magic, and it's going to be magic all semester. I'm never going to tell you what that does. Okay? It's just magic. Do you want to know what it does? I'll tell you. I'm not going to tell you. It's too complex. On the last day of class, if you remember to ask me, I'll tell you what it does. But for the most part, we don't care in this class. Okay. All right, int main, open close parentheses, is really where things start. Okay? As we're going to see later in the semester, we can have a bunch of stuff between the pound include IOStream and using namespace standard and int main. But this is where, whenever we start looking at a program to figure out what it does, you start reading right there. I have in the past acted as an expert witness in patent litigation. What they essentially do is give me all the code from something, and they say, figure out what this does and tell us if it does the same thing as this patent. And one of the first things I do when I read the code is I find where it says main, because that's where I start reading code from, because that's where the computer starts from every single time. Okay. Okay, so that's start. And then we know about start. Okay, so now we're going to have to input a choice for int or floating point division, okay? Which means we're going to have to input something. If we're going to input something, what do we need? Yes? We need a place to put it, which is going to be a variable. Okay? So let's declare a variable. What we're going to declare is a char, which is short for a character, and we're going to call it choice. So what this does is it says, make space over in memory for us. It's going to be named choice, and it's able to hold char, which is one single letter or character. Okay? We'll talk about types in just a minute. Okay, so if you remember, we talked about 4 basic data types from the other class: int, float, char, and boolean, or bool. And a char just holds one character. Now I'm going to show you, you can put You can put comments after a variable if you want. It's just that the comments have to appear after the semicolon. And as a style thing, you don't really want your comments going way, 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 way far away. In fact, when I write code, I almost never use end-of-line comments. I almost put the comments right above it. But that's a style choice. Okay, so we're going to input a choice that holds floating int or floating division. What else do we have to input? We have to input some numbers to divide. So what do we need for those? Variables to store them in. So they're going to be ints because we're dividing two ints. And now we want to name these things something meaningful, right? One of the things about your code, one of the things about making your code readable by other people, is to use variable names that represent what that variable is being used for. Yes? We're using int because that's what we use to hold an integer number, a number without any decimal points. And I haven't finished this statement yet. I've just left it hanging. So variable name choices matter because they make your code more readable. Now we could choose something like, x and y, right? That would be legitimate. But does it really mean anything? Like when I see x and y, I think of like Cartesian plane, right? So you have to choose variable names that work well. Sometimes what people will do, we can call it int1, and int2. Those are good names. As things go along in the semester, we will have longer and longer variable names that actually have some meaning. Okay? So I'm going to take a moment and I'm going to tell you a little bit about variable naming. Okay? So there's different ways to name variables. One way that some people might choose is they might say something like integer input 1, like that. This is actually kind of a C style name, and this is separated by underscores. Okay? The other way you might choose to do this is you get rid of the underscores and put things together, but you capitalize words. And this is what's often called camel case. Yes?
Is there a limit on how long the variable is?
No. Well, maybe. I don't know. I've never reached it. So when you choose names, you essentially can choose things like this. Okay? There are different programming styles. In preparation for this class, I went online and I found the Google official C++ programming style guide. And I've decided that all my solutions that I write for the class, I'm going to try and stick to the Google C++ programming guide. Now, Google uses the first for variable names. It uses things separated by underscores for variable names. For other things, it uses this capitalization, or what's often referred to as camel case, because you get like humps in the middle. Everybody with me so far? Now, when you choose variable names, there are some rules about what variable names you can have. Okay? Now, they have to start I'm sorry, let me rephrase that. When you choose a variable name, there are rules that governs how it's created. And in essence, everything has to be a letter, a digit, or an underscore. Okay. So, when we talk about variable names, they have to be composed of letter, digits, or underscores. So, for example, would dog, say we're going to just declare some variable names, would dog be a valid variable? Why? Great. How about dash cat? Why? How about we did underscore cat? And then we got rid of the That's valid. And in fact, some coding styles put an underscore in front of variable names to have a particular meaning that I will not explain to you right now. Okay? But sometimes they have meanings. Okay, so essentially it's pretty easy. And I'm not even sure. Hang on a sec, let me check my notes. In fact, did you see this turned yellow right here? It's because the first letter cannot be an underscore. Sorry about that. Okay. And anyway, I was confusing a different language that did underscores at front. Some things use underscores at the end to tail things. So that is valid. Sorry about that. Okay. So first thing has to be a letter or a digit. Everything else has to be a letter, digit, underscore. You can have quite a few of them together. Okay. Sir?
So will we be allowed to use either
Yes.
both of the?
So the question is which variable naming scheme do you get to use? You get to use whichever one you like, as long as it's neat and consistent. I am using the Google one just because I was kind of curious what Google used, and I just thought I'd write some code that way. But, okay. So when you look at my solutions, my variables will look like the top one rather than the bottom one. All right. Now sometimes, I just want to tell you this too, sometimes we will have numbers that we need to have that never change. They are not a variable. Things that are not variable are constants. Okay? There is a way for us to define numbers that never change. For example, if we were going to work with circles, what might be a constant that we would want to use? All right? Except I forgot something. I have to tell what is float. Yes?
Does C++ also have like a math function though where we already have pi?
Yes. But say we wanted to create a variable. If we didn't want to create pi, we could create something else. If we wanted to have something that was a floating point number that didn't change, and in this case, pi you can get elsewhere, or you can create your own.
Is this like static?
Sort of, yes. But don't use that word in this class. You're going to scare people. It's more like final. Okay. Okay. There's also a static keyword in C++. If you have no idea what I'm talking about, that's fine. I like it that way. Okay. So essentially what this means is we're going to declare a variable. This is the type. This is the name. This is the value. But const means you can never change it. If you ever try to change const, like later we go on and we say, hey, I don't like pi being equal to 3.1415. I want to make it equal to 22 divided by 7 or something like that. The compiler will say, nope, this had a const in front of it. You are not allowed to change that, ever. Once it is set using const, it is fixed in stone. Well, silicon electrons, but stone. All right. Make sense? So a variable declaration is a type, a name, and then optionally an equal sign and a value. If you want to make it so it can never be changed, you use const. Now I'm going to tell you, since I'm using the Google style guides, consts in Google code are always represented by the letter K first, and then camel case afterwards. Okay. Again, you don't have to program this way, but when you look at my code, this is how I've labeled all the constants. Question? Okay, so the question is, why would you use a const instead of using a variable and never changing it? And the answer is twofold. The first is that when other people read your code and they see the word const, they know it's something that is never supposed to be changed. The second thing is that you're programming on your own right now, but programming is a team sport. You don't want other people to accidentally come along and write code that changes something you expect to be the same. Does that make sense? The other answer is it also, that's all for this class. Those two things. Okay. The third answer is that it gets put in a different place in RAM than other stuff, but That's why. All right. So everybody kind of understand how we can declare data types, declare variables, and we can declare something constant so that it never changes. Okay. A word about const. Const is pretty nice to use in programs where you have constant values. But if you just stick them in the program, it's not clear what they are. For example, say I gave you a program where I'm dividing something by 7. Why did I divide it by 7? Anybody know? How about if I'm divided by something that says k number of days in a week? Why am I dividing it by 7 now? Because it's the number of days in the week. So one of the nice things to do is if you have a program that's going to have a lot of values that don't change, instead of just writing those numbers in as literals, which just means as a literal value, make them a constant and give them a name. It is easy for us to read through an algorithm and recognize things by name and think about what that name means, rather than trying to guess what that particular integer represents. Does that make sense? In the program you're going to have to do for the first programming project, there are a lot of constants. I think there's like 80 or 100 or something like that in my solution. There's a lot of them, okay? It helps a lot if you have a good naming scheme that indicates what they are, rather than just putting them in there. The other thing is that in the program we're going to write, and I'll just tell you what it is right now, it's a heart attack risk scoring calculator. And essentially you get some input and you figure out a whole bunch of stuff based on constants, and it tells you what your risk of a heart attack is in the next 10 years. In there, all these numbers are based on studies, right? They do scientific studies over a large population, and they figure out what what is going on with the population, and based on that they come up with these scores. If as they go along they end up changing the scores, it's annoying to have to go through the program and find every single place that score is. But if you just defined it as a constant up at the top of your program, you change it in one place, and then it automatically gets changed everywhere else. Okay. So, yes? Yep. So let's make const int days. Well, I'm going to use the Google naming scheme. Now, is the number of days in a week likely to change anytime soon? Not really. But if you see days in week, do you know what that 7 is, right? I don't know. Let's pick something else, right? We could do like const int k my lucky number, right? Const int k floor of my apartment. And so if all of these things happen to be in your program and you were just using 7 and you moved, right, or 7 became unlucky for you for some reason and you wanted to change it, you can't just search and go through the program and replace every 7 with something else, because the 7s might mean different things. Does that make sense? Yes, and then we'll get back. Yep. Sure. Yes. As long as you pick something consistent that's readable, it's fine. You're going to develop your own programming style as you go along. Often what happens is, different places have their own programming styles. I'll put up a link to the Google programming style. It's way more complicated than we need, but has some of the stuff. As long as you're consistent, I'm not going to force you to use the Google programming style. Okay? Yes? Yeah. That's exactly what we do. Like later we go, God, 7 was a really bad number. 19 is going to be my lucky number from now on. Now it's changed. When you recompile it, the compiler finds every place where that name is and puts the correct number in. So yes, when you recompile it, automatically changes it. Yes? This is the Google programming style to let you know that it's a constant. K is just short for constant. You don't have to do it that way. Like I said, I just figured that instead of just like saying you can do whatever you want when in fact you have no experience in doing anything, I would just use the Google programming guide for my programs, and I'm just going to do them on the board. You don't have to follow it if you don't want to. But, maybe one day you'll interview at Google and you'll be like, yeah, I already program using your style. And they'll be like, really? And they'll say, what do you do for constants? And you're like, K, camel case. And they'll be like, oh my God. Yeah. Yes. Most of the time when we're declaring variables, you declare them up at the top by int main. And when we start writing our program, I'll show you that there. Okay? Yes? Yes, absolutely. So, here we had days and week had 7, and we had floor of my apartment also was equal to 7. It's fine. Whatever. It's just better to put things in names that make sense, because when other people read your code, it makes more sense to them. Then instead of just saying 7, and they go, gosh, are they talking about the days in the week or which floor their apartment's on now? Because I don't remember which is which. So, yeah. Yes. But go ahead. No, you caught me out. Normally you can do every single thing except that. A constant, you cannot easily have user input turn into a constant. So you'll never need to do that in this class anyway, and I'll tell you, I've never needed to do that. So, yes? If you, just because this k is here has nothing to do with the fact that it's a constant, it's just a naming scheme. If you wanted to trick the other programmers by putting k there, then they would look at you and be like, why did you put a k there? It's not a constant. And you'd be like, I was trying to trick you. And they'd be like, you failed, right? So that's pretty much what would happen. So but putting the k there doesn't make it a constant. It's just a way of noting that this is a variable constant. And is there a way to input something that can never be changed again? Probably. I mean, I've never had to do that. All right, everybody happy? All right, so this is essentially how we declare variables and how we declare constants. All right, and you're going to have plenty of practice of this. Okay, let's go back and take a look at our program we were working on. So we have to input something as a choice. Do you like choice as the name for the user choice? What do you want to name the two integers that we're dividing? Yeah, this is pretty simple. I'm going to go with int1 and int2. It's not perhaps... Now notice that when I declare variables, I can put a comma between them, and I can declare multiple variables at the same time. And in fact, just to make sure, here's how I write my code. When I do things, I like to jump down. I actually like to compile them every once in a while as I go along, just to make sure that I haven't introduced something. Okay, so if we do this, g++ divide, okay, I compiled. Did I get any errors? Everything is syntactically correct. That doesn't mean my program is done yet. And if I want to run it, I can type a/.a out. All right, and it doesn't do anything yet because we don't have any input or output. Now, I actually don't like typing ./a.out all the time. I think it's annoying. So what I do when I compile my code is I do -o and then the name of the program. Okay. Did I show you this before on the screencast? Okay, good. So now when I want to run my program, I can just type divide, and it runs, and it's no problem. So G++ with .cc, if it just by default puts it in a.out. But if you do -o and what you want the program name, that's short for output, -output, and it puts it someplace else. So the name of the file is different. Okay. The other thing you can do if you want is you can do mv. You can just move it, and that renames the file in Unix. By the way, this is Unix or Linux we're using. Anybody ever seen Jurassic Park? It's an old movie. There's a scene in there where the girl runs up to a computer, and she's like, oh my God, I can't remember what she was doing. And she looks and goes, hey, this is Unix, I know this. Which was pretty cool. So if you're ever being chased by dinosaurs, this might be a useful skill, according to Hollywood. All right? All right, so we've tested our code as we go along, and we haven't introduced any glaring errors. All right? So here's what we can do. We've declared int1 and int2. All right. When we declare a variable, what value is in them initially? We don't know. We don't know. So as good practice, you know what I like to do? I like to go ahead and initialize almost all my variables right when I declare them, just so that I don't suffer like I suffered the time that I forgot to initialize something, and it took me like days to figure out why I was getting random values in there. So it's a defensive programming. So what you can do is when you declare it, you can also give it an initial value. And this is just a safety thing, okay? Computers are dumb. They're dumb very, very fast, but they're going to do exactly what you tell them to instead of what you meant for them to do, right? So what's going to happen is if you make a small mistake programming, the computer is going to run with it very, very fast, right? They're going to run with it and they're going to be like, that's what you told me to do. So if we forget to initialize some variables and we use them later on, it can create problems for us. So over the course of the semester, I'm going to show you some things that I do just so that it limits the number of things that I can screw up, okay? And this is one of them. Doing an initialization of your variable up front is a good idea. So we can initialize an integer by giving it a 0. If we want to go back and initialize choice, you can initialize choice by giving it 2 single quotes with nothing between them, okay? If we're going to have a letter for choice, you can put the letter in between the single quotes. Let me just make sure that works because I've been doing a lot of Java programming recently. Got a space in there, sorry. Okay, so I had to give it a character and I put a space in there. So now our choice is initialized to a space. Sir? Yes, C++ does not initialize anything. If you are a Java programmer, this is a trap, right? Because you will expect things to be initialized and they will not be. Okay. They will not be. Okay, other questions? All right, so here we go. We have initialized our choice, we've initialized some things, so now we can actually go ahead and input things. How do we input? CN is what we use to input. So now we can input our choice, right? So we declared variables. Let me just clean this up a little bit. All right, we declared variables. We input a choice for the first number for inner floating point division. Right. So let's compile our program and see what happens. It compiles cleanly. Let's run it. And it's just sitting there. Why is it just sitting there? Yeah, the computer's dumb. It's dumb fast. It said, okay, I declared the variables. Now I'm waiting for some input. Give me some input, you big, slow, dumb human. Right? How, as a user, am I supposed to know that? Pardon? You need a message, okay? If you ever get to a point in your program where your program's running and you want it to stop, you can stop it by typing Control-C. So rather than input, I hit Control-C. And what we really want to do is we really want to go back out and say what our choices are. And so we could say something like choose, you know, but we have to let the user know what format we're expecting it in, right? If we say integer or floating point division, what might the user just do? Yeah? Yeah, they wouldn't know, right? So what I normally do is I normally say, you know, I or D, something like this, when I use So now I'm outputting stuff, and this is going to give us a chance to see how cout works a little bit. We'll talk about this more, but essentially what cout does is it says, starting here, I'm working from left to right, just read along, and every time you see one of these angle brackets, this is essentially the funnel that goes straight to the screen. I like to think about this as a funnel, and I go, okay, I'm going to take this whole long string, and I'm going to shove it into that funnel, and it's going to appear on the screen. That's a very technical explanation, but that's the way I think about it, okay? Yes?
Why can the output go before the input?
We're going to do output before input to give the user a message so that they know what they're supposed to input. When I ran the program before, it was just sitting there blinking at us.
Yeah.
Now I'm actually going to tell it what we're expecting, okay? So let's compile it and see what just happened. So now it says choose integer or floating point division, and we tell it, give it an I or a D. Right? Which do you want this time? Great. Well, we haven't written the rest of the program, but we've gotten to the point where we can choose things, and it read the choice. Yes?
So the I or D choice is something C++ just knows?
Nope.
If you type I, that's what it...
So if we go back and take a look at the code, here's what's happening, right? So right here we're saying choose an integer or floating point division, and we're telling it a letter I or D. And what this input is we're inputting choice, and choice is a character, which means a single letter. I or D is a single letter. So what's going to happen is, assuming the user does not screw up, which is a huge assumption, that there's going to be either the letter I or D will be stored in this variable choice.
Oh, okay.
Okay? Once it's stored there, we can start making decisions of it, but we have to go get it first. Okay. Sir?
Does it matter whether it's capital or small?
It does matter. Sir?
How does the computer know which one is integer or float?
The computer doesn't know anything. The computer never knows anything. So let me tell you my motto. Do you all know the word anthropomorphizing? Do you know what that means? Giving an inanimate object human qualities. So stop anthropomorphizing computers, because they don't like it at all. Okay? No, the computer knows nothing. The computer is a dumb box that can add numbers and process letters very fast. So all the computer knows is what you have in your algorithm, and we're going to have to tell it what to do with that letter. Okay. Yes? Sure, we should add a condition. And I'll tell you, reading user input is very painful in computer programs because computers are so literal in what they can do, and because people are problematic. Okay? I like to tell my security class, people range from imperfect to suck. Right? At best, we're imperfect and we're going to screw things up. At worst, we suck and we're going to purposely screw things up. Okay? So, at best, people are imperfect and they're going to enter the wrong thing, so we have to handle that. If you ever read code that does read user input, about 30% of the code is nothing but error checking to make sure that whatever the people entered isn't something that you didn't expect. Okay? A lot of code goes to checking user input. We will not do as much of that in this class because it gets very tedious and doesn't add much to your education, but if you ever got in the world and start programming thing that takes user input, you're going to see there's a lot of stuff. I mean, people do crazy things. They'll hold down, like, Shift Alt Command 8, and things like that, and you get weird characters, and they'll enter things in a foreign language, so you have to be able to handle that. Okay? You don't have to do that in this class. We're going to keep it simple initially. Okay, so now we inputted the choice. What else do we have to input? Okay, so do you just want to input them, or should we warn the user what we're expecting? In general, we want to warn the user expecting, so we say cout. Okay. So what we're going to do is we're going to say input two integers separated by a space. Question, yeah? Excellent. So the point is that the input message I put out doesn't specify which one is the, quotient and divisor? Did I use those terms right? Any math people? Math majors? No math majors? Quotient and divisor? Okay. Is that right? Do I have to look it up? What? Oh, okay, great. Input the dividend and divisor. Now, a lot of professors would be embarrassed by that, not knowing that, but I'm a computer science professor. I always prefer to crowdsource things when possible, so that worked quite well for me. Okay, so instead of just saying enter two integers, we say input the dividend and divisor separated by a space. Is that better? And in fact, you know what? Now that we've done that, let's just go back and make our variable names better. How's that? Right? That's much better for people who are reading our code than int1 and int2. So I'm actually very happy with that. Thank you. Emily, right? Do you want some candy? I have a whole bunch. Okay. All right, so we're going to input the integer, the divisor and dividend and divisor separated by space. And here's what we do: cin into dividend and into divisor. Now, this looks a little bit strange to you, right? Because it says cin goes into dividend. Again, remember how I like to think of these angle as a funnel thing? Cin is the keyboard, and we're cramming stuff into this funnel that ends up into dividend and into divisor. And what cin can do for you is it will find multiple things that are separated by a space and stuff them in there. Okay. So if we're going to run this now, and let's compile it and make sure we didn't introduce any errors, we can say I want integer division, and I want to divide 23 by 7. Okay. Now, do we know if that worked or not? Why don't we know if it worked? Because we didn't get any output. Okay, so the other thing that I often do when I'm writing programs is I will occasionally put in some output statements that just let me see what's going on inside the program as I go along. So I tell you what, let's just put in the output. Now, cout, like I said, you read from left to right. Everything you see, you stuff into these little funnels, and they appear on the screen. So the first thing that's going to come out is say, I got, in double quotes, and then dividend. This is the first time we've seen a variable being printed out. And when you print out a variable, all you do is put it in there without the double quotes. What will happen is when the computer's running and sees this, it'll go, okay, I print out I got. It'll get to here and it goes, oh, dividend. It's not in quotes. It must be something I'm supposed to know about. And it looks up and it goes, oh, look, here was something called dividend right up there. I will find that value and I will stuff it into the funnel so it'll appear on the screen. Then it goes on and says, oh, space and space. Divisor, it goes, oh, I've seen divisor before. That's also a variable. I will get that and stuff it onto the screen. And then finally, it will, end-L means anything that gets printed starts getting printed on the next line. So let's take a look at that and see what we got. Okay, so we'll compile. I didn't introduce any errors. Divide, we'll do integer, 22 divided by 7. And we can see it says now I got 22 and 7. So does our input seem to be working? Excellent. Now that we know our input's working, you know what I do? Let's go back and take that out. So as I'm developing my algorithm, right? I outline the algorithm. I start putting steps in C++, and then I add statements that allow me to test and check and make sure that what I've done so far is correct. And when I'm done with them, I take them back out because they're not part of my algorithm. They're just a step in the algorithm that I've added to make myself sure that what I'm doing is correct. Okay. Yes?
Is it possible to just put a double slash in front of it?
Yeah, sure. Yep. Yep, we could also do this. You can leave some debugging statements in there. I often do that too. Typically what I do if I'm writing a large program is I comment it out initially in case I screw up something and later I have to go back and uncomment it out. And then before I do the equivalent of submitting the program, I go through and I take out all those. Just because, there's kind of a debugging statement. So, okay. This is called a debugging statement, by the way, this output. So you can have some debugging statements in there that show you what's going on. Does that make sense? We didn't do a debugging statement for choice. Should we do one for those really fast? Who wants to tell me how to do a debugging statement for choice? I've got this red wrapped Reese's peanut butter cup for you. Yes, sir. Uh-huh. Mm-hmm. Mm-hmm. Wait, you have to tell me. Why am I doing this? I get a cut now. Uh-huh. I just call these the angle. Yeah. Okay. Let's just see if that worked. Okay. So we're able to see that we got a lowercase I, which is what I typed. Question? Yep. Yes. C in you can input multiple things. C out you can output multiple things. Okay? And in fact, we do see output multiple things here, right? We output this quoted thing. Oh, where's one? Here, let's go back to this one and uncomment it. Okay? Here we output that little message. We output what dividend is. We output the space and space between them, and then we output divisor. Yes, they are. CN, like I said, I like to think of them as funnels. Like really, I have struggled over the years with an analogy for how to do this. And I've tried different things like if anybody's ever been to a sushi restaurant that has like a little conveyor belt, or it's like a conveyor belt going to the screen, and when you put the first thing on, it carries it off to the screen. But the way I think about it is funnels, right? This just gets stuffed into the funnel, and every time it goes into the funnel, it appears on the screen. It's like the magic. It's like when you jump into a pipe in Mario Brothers and you go down. See, I still don't have a good analogy. Nope. The computer never knows anything. All the computer knows is how to do this mechanical processing, and our algorithm has not made any use of that input yet. So we're going to have to specify what to do with that. And that's what we'll do next class, because it's about time to go. So, all right. I owe some people candy. Who do I owe candy from last class? Ah, whoa, look out, sorry. You okay? You can have that one. Did I owe you candy? You sure? Anyone? I do. I have office hours today from 1 to 2, so you can stop by. Yeah?
I did the homework, and when my CC came up on my desktop because I downloaded it, it's just like the icon for it's just like a blank box, just like a little blank box.
Okay.
I don't think is that just because my computer can't read the CC document and doesn't have anything.
Yeah.
Okay.
You on a Mac?
I have PC.
Yeah. It just doesn't know what a CC file is, so
Okay, thank you.
that's all.
Are you gonna post this stuff online?
Yeah, I'll post these things online.
I've been trying to connect to Saxonet, but it says connection timeout every time I try
Uh-huh.
to.
You got to go talk to UIS about that.
Okay, where is there a...
They're in the basement of St. Mary's Hall.
St. Mary, okay.
Yeah.
And
So-
also, I think I lost the earlier accommodation form.
Oh man, I only give you one. Only get one shot. Not really.